Go. All right, guys. Welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video. All right, so for the warm-up, we got to do factoring because we're going to be using a lot of factoring today, okay? So number one on the factoring, what you want to do first is set it equal to 0. How would you do that? Plus 6 on both sides. That is correct. So then you get x squared minus 5x plus 6 equals 0. Now, there's something that you would do before you go straight into the A, B, and C. Does anybody remember that? Only one person's told me that today. What? Okay, so the idea is right. You check for the greatest common factor. That's what it's called. The greatest common factor, right. There is no greatest common factor here because A is 1. So we can go ahead and write our A, B, and C, right? So what is A here? 1. What is B? And what is C? Good. So now we're going to draw the X box over here. So what goes in the top space again? A times C, which is going to be? Negative, or you're confusing me. It's positive 6. And what goes in the bottom? B, which is negative 5. That's right. Okay, so you got to find two numbers that multiply to give you the top number and add to give you the bottom. What are those two numbers going to be? Very good. Negative 3 and negative 2. Now, there's one more thing we have to do before we can write out our factors, and what is that? So you write a fraction line above that number, and on top, what goes on the top? 1, just 1? 1x. So 1x is the same thing as x, so you can just write x. So now we can see our factors. You want to make sure that the fractions are reduced as much as possible, but they already are because it's just 1x. So the factors here are x minus 3 times what? X minus 2, right. Equals 0. And then you what? And then you bring them out? Okay, yeah, so x minus 3 equals 0. So x equals? 3, that's right. So one of the answers is x equals 3. What's the other answer going to be? X equals 2. That is correct. So there are your answers. X equals 3 and x equals 2. Very good. So let's do the second warm-up problem. This one's a little more complicated because A is not 1. All right, so first things first, we want to make sure it's set equal to 0. It is. Is there a greatest common factor there? There's no greatest common factor. So we can just go to the A, B, and C. What is A? B. And what is C? That's right. Okay, so let's draw the X box. Boom, boom. What goes in the top? Negative 12. A times C. What goes in the bottom? Negative 11. That's B. So what are my two values going to be on the sides? 1 and negative 12. Very good. 1 and negative 12. Oh. 1 and negative 12. Okay, now what goes on top of these numbers? 3x. Very good, because it's A, which is 3 times x. Now, what do we need to do? Can I just write my factors like this? No, you have to. Got to reduce 1 over 4. So x over negative 4. Right. So now both of the fractions are reduced as much as possible. We can write out our factored form. What's it going to be? 3x plus 1 times x minus 4 equals 0. Right. So then we have to solve for x. And how do we do that? We set them equal to 0. 3x plus 1 equals 0. And x minus 4 equals 0. The x minus 4 equals 0 is just going to be x equals 4. How do I get this other one? Subtract 1. So 3x equals negative 1, and then? That's right. So we divide by 3, and we get negative 1 over 3. So there are my two answers, negative 1 over 3 and x equals 4. Very good. So this is just a refresher to make sure you know how to factor, because we're going to be using factoring in what we're doing today. All right, so what are we doing today anyways? Is going to be about extraneous solutions in root equations. So if you look at this box right here, pretty much this explains it. But yesterday when we were solving for square root equations, I just highly doubt somebody checked all their answers by plugging numbers back in. But it really didn't matter yesterday because everything worked out just fine. However, today forward, you're going to have to check your answers. Because sometimes you're going to get extraneous solutions. Do you remember what extraneous solutions are? What does that word mean? Anybody? No one knows what an extraneous solution is? An extraneous solution is when you solve and you get a solution, then you plug that solution back in and it actually doesn't work. So it's an extra solution. It's an extra solution. It's not actually a solution. All right, so we can get those extraneous solutions when we're solving root equations. And why is that? Well, watch this. So in math, things need to make sense, right? So if I write 4 equals 4, does this make sense to you? Is this a true statement right here?
Yeah.
Did you just say no? 4 equals 4.
Oh, then yeah.
Yes, it is. 4 equals 4, right. Okay, now whatever operation we do, we perform on this equation, whether we add a number to both sides, subtract a number to both sides, multiply or divide, right? Then it's still the same thing. It's still true. So, for example, give me an operation. Tell me an operation. Like addition, subtraction, multiplication, whatever. Give me something. You want to add? You want to subtract? You want to multiply? Add? What do you want to add? What number?
10.
So we add 10 to both sides. Now what is it?
14.
Equals?
14.
It's still true, right?
Yeah.
Started off true and it ended true.
Yeah.
And that's how it should be. Okay, that makes sense, right? Now why doesn't this always work when we're squaring things? Now remember yesterday we got to a point where we would square both sides, right?
Yes.
Okay? And that is where problems arise because look at this. -5 equals 5. Is that true? -5 equals 5? No. But watch what happens when I square both sides. -5 squared equals 5. Squared? What's -5 squared?
25.
What's 5 squared?
25.
Because I squared both sides, look at that. Now it's a true statement.
Yeah.
But I started off with something that's not true. And you can't do that. And this is what the problem is. Because how do you know that you actually started off with a true statement when you square both sides? You don't unless you check your answers. Okay? So this is why you can get extraneous solutions when you're solving square root equations. So let's take a look at how this will appear in our problems. This right here is the logic behind it all, why these extraneous solutions even appear. Okay. So example number 1 right here. Let's just go ahead and just solve this. What would you do if you wanted to solve this problem right here? You square both sides, right. And if you square both sides, what do you get? -4 squared. Now when you square the -4, make sure you put parentheses around it. Okay, that's very important. Because if you don't put parentheses around it, then you're actually saying to square +4 and then just stick a negative sign onto whatever the answer is. That's not the same thing as -4 times -4. Okay? So what is -4 squared? 16. And then how would I solve this?
You add 3.
Add 3. Very good. So x equals
19.
19. However, if you were to circle that answer and say, here's my answer, this is the right answer, then you'd get the question wrong because you didn't check your answer. And this answer doesn't actually work. How do you check it? You say x equals 19, right?
Yeah.
So we're going to plug that number back into the x, into our equation up here. So we're going to put 19 minus 3 equals -4. What's 19 minus 3? 16 equals -4. And what is this? There's no negative sign in front. It's just positive square root of 16. So what is that?
4.
So now you have 4 equals -4. Is that true?
No.
No. So this, x equals 19, is an extraneous solution.
You just square it here.
X equals 19 is an extraneous solution, which means that you didn't actually get any solutions that work, right? You only have just an extra solution that doesn't actually work. So what's your answer to this question? No solution. That's right. No solution. Extraneous solution is just a way to describe the solution. But your actual answer is no solution because you didn't get any solutions that worked. right? You only got extraneous solutions. Okay? So that's how you would know by working it out. Now let me show you a logical shortcut to knowing that this is no solution. You could just look at this question from the very beginning and know that the answer is no solution. How? Because you see how it's a square root of something, right? It doesn't matter what's in there. It's square root of something. And then it says equals a negative number.
So if it's negative, it's extreme.
Yeah, have you ever taken the square root of something and it comes out negative?
Yeah. No.
How? Because the square root of 25 is positive 5, right?
Yeah.
Square root of like 1 is positive 1, right? So, and even when we graphed yesterday, remember this, the lowest x value we could get is 0. And it only goes above the x-axis. So square roots cannot equal negative numbers, okay? That's how you know it's no solution. If you get something like that, it doesn't work. And let me show you something else. This is very useful for standardized testing and when you have a calculator. Obviously, we don't have calculators, but on finals and SAT stuff like that, you can use calculators, right? So watch this. Oh, let me write this first. So looking at your equation, what's on the left side of the equation? Right here. What's on the left side?
Yeah.
On this equation right here, what's on the left side of the equal sign? Square root of? X minus 3. So I'm just going to make that into its own function, so f of x. And then I'll just put like g of x. What's on the other side of the equal sign?
Negative
4.
4.
So I'm just going to turn that into two separate equations, okay? And on a calculator, if you were to graph these two separate equations like this, f of x equals, what is x minus 3? That green is the x minus 3, and then g of x equals negative 4, right? Well, the solution is supposed to be where they cross, right? Now look at them. Do they cross? No. And so that's how you can know immediately by graphing that it is no solution. There's no solution there. Because they don't cross. Okay, so that's a good way to either check yourself or on testing you can just find your answer like that if you wanted to. All right. So going to number 2 then. This one's a little more in depth. So what do you do first on number 2 to solve this problem? Square both sides. And what do you get when you square both sides? Oh, by the way, I think your paper says minus 8, right? Change it to plus 8. It's not going to work if it's minus 8. So change your paper to plus 8. Okay, so you said the first step is to square both sides. When you square both sides, what do you get? Equals x squared, right. So now you can see this is going to be a problem where we have to factor in order to find x, right? So what do we need to do? Subtract what? Subtract 8. Okay, what else do we need to subtract? The 2x. Because remember, we're trying to factor, right? So we need to set it equal to 0. So what is my equation going to say now after that? 0 equals, as you're saying, x squared minus... Right. Okay, and why did we subtract 2x and subtract 8? Because when we do it this way, our x squared stays positive, right?
Yeah.
You don't want a negative a value. Remember, I don't know if you remember this, but we never want a to be negative, okay? So it's just like this, and now we're ready to do our factoring process. So check the GCF. Is there a GCF?
Yes.
A is 1, so there's no GCF.
But 2 can go in 8.
But it can't go into this 1.
Oh, no.
Yeah. So we can go ahead and do our A, B, and C. What is A?
1.
What is B?
Negative 2.
And what is C?
Negative 8.
Stop copying me. All right, so draw the X box. What goes in the top?
Negative 8.
Negative 8. What goes in the bottom?
Negative 2.
And so what are my two side values going to be?
Negative 4, negative 2.
That was fast. Wow. Nice. Okay. And what do we do after that?
1 right?
Right. X is going to go on top because it's 1, which is A, times X.
So it's already simplified?
Right, it's already simplified, so what are my two factors?
Minus 4 and then x plus 2.
So you're right, if you solved it out, you'd have like this, x minus 4 equals 0, x plus 2 equals 0. Right, this is like, if you know this, then you know this. I'm just showing because people who want to, see this video maybe need to see this. Okay, x equals 4, x equals negative 2. Oh, look at this. Can it just stop though? Can it? There. Where am I? All right. And the zero's running away. Okay, hang on a second. Things going crazy in here. All right. Okay, so we got two solutions, right? But you have to check if either of them work. So just by looking at the solutions, what do you think is going to work? What do you think is not going to work, if any?
4.
You think 4 is going to what? Work? Or you think 4 is going to work because it's positive? Okay, so what are you saying about the negative 2 then? Could you explain that again?
Whenever you square root something, it doesn't come out negative.
Right, so that's a good explanation. So when we check it, we're going to plug those numbers back in for x, right? Well, when you plug in the 4 back into the original equation, it's going to be like 2 times 4 plus 8 equals 4. That's fine because it equals a positive number, right? But when you plug in the negative 2, it becomes 2 times negative 2 plus 8 equals negative 2. See how on the second one, when we plugged in negative 2, we have a square root equals a negative number?
Yeah.
So right there, in that very first step after you plugged it in, you could tell that the negative 2 is not going to work. Right? You could tell that the negative 2 is not going to work just from that explanation. However,
You want us to plug in our work on everyone?
well, you need to check to see which ones work, right? Because if you got these two solutions and you said both of them are answers, then you'd be wrong. Right? Yeah, you got to circle which one works, if any, because sometimes neither of them are going to work.
What do you mean by like not working?
Well, okay, well, if we solve it out, right? So we plug these numbers back in, right?
Yeah.
So look at this left one. 2 times 4, what's that?
Negative 4.
No, 2 times 4.
Oh,
8.
8.
So 8 plus 8,
6.
right? That's 16. What's the square root of 16?
4.
And so isn't this true?
Yes.
So then that did work. So x equals 4 is a solution, so we can circle this one. Now the other one, look, the other one, like I was saying, you already know it's not going to be a solution because, look, it says the square root of something equals a negative number. Right. You can't have the square root equaling a negative number, right? If you recognize that, you can stop there and just write that or show that it's negative and then, that's good enough. But if you didn't get that, because some people do forget, right? Like maybe you don't think about that on the test. So if you do forget, you can just work it out and you'll get the same thing. Because let's work it out. What's 2 times negative 2? Okay, so you got negative 4 plus 8 equals negative 2. What's negative 4 plus 8?
12? 12?
4. So what is the square root of 4?
2?
Is 2 equal to negative 2?
No.
No, so you can see even if you work it out, you're going to get the same result, right? That it doesn't work. So x equals negative 2 is not a solution. That's an extraneous. Right, so your answer is, yeah, that's right. So your answer is 4. However, don't be confused because just because you see it's a negative number, that's not enough information to actually tell that it's not going to work. Once you plug it back in, though, then you can tell.
Yeah.
Okay? But don't just look at it and say, oh, x equals negative 2, that doesn't work. Plug it in, and then from that very first step, then you can tell. Okay? Because you'll see, we're going to look at an example later where that really comes into play. All right, now also, let me just show this to you because it's a good thing to know. Once again, if I took each side of this equation and put it into a graph, right, you're going to see, what was on the left side? Square root of, what is it? What was under the square root? 2x plus 8. And then it's x, right? 2x plus 8. Okay, check this out. Look at the graph. When I graph those two sides of the equation, look at the cross, right here. This is where they intersect. What is the x value right here? 4. So that's how you know the answer is going to be x equals 4. Because where they cross, the x value is 4. You see that? Now look at negative 2. Does it cross at negative 2? No, it doesn't. So this is a way that you can see visually that x equals 4 is your only answer. Okay? And just to show you how great of a tool this is actually, I'm going to show you from the beginning on number 3. Let's just say you had your calculators right and you could graph it from the beginning. So 7x plus 18, I'm going to graph that. 7x plus 18. Or you could do it by hand, but that would take forever. Or take some time. Now look at this. This is what the graphs would look like. What is the x value right here where they cross?
8.
It is a 9. That's right, it's 9. So that means your answer should be
X equals 9.
x equals 9. Very good. Because x equals 9 is where they cross. Do you see that?
Yeah.
So then you should know already x equals 9. You could, so, on a test that you could use the calculators right, then you could do this and boom, there it is. That's your answer. But we're going to show you manually, working it out, that you're going to get the same answer. And this just really good to show you how much time it saves, right? Because we just did that super fast, and then now we're about to do it by hand. All right, so what do we do first then if we're trying to solve this by hand? Square both sides, and what does that give you?
7x plus 18 equals x squared.
That's right. What do we do next?
You
Subtract 10.
Subtract 18 and also 7? 7x.
7x going to be left on the other side.
0. Remember, we want to set it equal to 0 so we can factor.
Oh.
So we have 0 equals?
X squared.
That's right. Okay, so now we have it set equal to 0. We check for the GCF. Is there a GCF? The greatest common factor. No, because A is 1. So there's no GCF. So what is A here?
1.
What is B?
-7.
And what is C?
18.
So those are all the X box then. Boom, boom. What goes in the top?
-18.
What goes in the bottom?
-7.
Whoops. -7.
-7.
And what are my two values going to be?
3 times 6.
3 times 6.
-3 and then
-9 and 2. All right, and then
X. The X is up it.
X above it, right?
77.
It's already simplified, right? So then that means your factors are
X minus 9. Times X plus 7.
x minus 9 times x plus 2. Very good. Okay, equals
X equals 9.
equals 0.
Oh, 0.
So then, as you said, x equals 9. Wow, stop flying around. X, hang on a second. X equals 9 and x equals -2. All right, so we get x equals 9 and x equals -2. Now remember from our graph, we saw that the answer is going to be, which one?
X equals 9.
Yeah, remember on our graph, we saw that x equals 9 is going to be our answer. So as we see here, that's one of our answers. You could plug it in as well and check, right, and get that one does work. And when you plug in the x equals -2, you're going to see that it doesn't work because you're going to have square root of 7 times -2 plus 18 equals -2. And right there you see that, once again, you have a square root equals a negative number, which doesn't work, right?
Yeah.
Okay, or you could work this all the way out and you're going to get like this.
So when square root always equals a negative number, it's not going to work. Is that what you're
When you say, when you have just the square root equals a negative number, that doesn't work.
saying? Okay.
Because it has to come out positive. Okay, so, or if you don't get that right, you could work it out and you will see that it's going to be square root of -14 plus 18 equals -2. This is square root of 4 equals -2. What's the square root of 4?
2.
2 equals -2, which is not true.
Yeah.
So regardless, if you get it by understanding that square roots cannot be negatives, or you work it out, you're going to get the same answer. Okay? So that's that one. And on to the last one. This is the most in-depth one right here. Number 4. Number 4, what do you do first here?
Add 5.
Add 5, very good. So we have square root of x plus 7 equals x plus 5, right. So these are still the same thing, right? We just rearranged it a little bit. So now it looks a little more clean. So I'm just going to go ahead and cross this top part out because we can just start with this equation. This will be our equation, okay? It's the same thing. All right? And you're going to see why I did this in a second. So what do we need to do now to solve this? Square. When we square, what do we get?
X plus 7
Squared.
Equals what?
plus 5 x.
Yes, that is right. You're the first person to say it today. Very good. In parentheses, x plus 5 squared, because you're squaring that whole side, right? So you can't just take each term and square it. This is a unit. It comes together in the parentheses, and then you square that whole unit. You see? And that's going to be different because, you know, in your mind, you probably would think at first it's going to be x squared plus 25, right? Is that what? Yeah, that's what a lot of people are answering today. However, this is different because right here, what does the x plus 5 quantity squared actually mean?
X plus 5, x plus 5.
Right, x plus 5 times x plus 5. And how do you solve something like this?
You do the moon thingy?
You do the moon thingy, which is foiling, yes. Or as we know, the moon thingy. For good reason. Look at that. Nice moon right there. All right, so x plus 7 equals, and if I foiled it out, what would I actually get here?
X squared
X squared
x plus 5
plus what?
plus x plus 5x
Plus 5x. You multiply them. And then? Plus
plus 5x
5x
plus 25.
plus 25.
Did you combine it?
Then you combine like terms. That's right. And so what would you get after you combine like terms?
X squared plus 10x plus 25.
Yeah.
And so notice, you know, if you thought the answer was x squared plus 25, right, that's completely different because you're missing a whole 10x, right? That's a pretty big term, you know? So it's very important that you keep them in parentheses together and then square the whole thing, right? Okay. So now we're at this step, and what do we need to do next to try to solve this?
Minus X.
-7 and minus x, that's right. -7 minus x. And so what does my new equation say?
0.
0?
Cube.
X squared? What?
Cube. Wait. So then what do you do with that plain X?
This x you subtract from the 10x right there.
Why?
Yeah, why not regular X?
Because these are both regular x's. This is x and that's 10x.
Oh,
What's 10x minus x?
Minus
Yeah, it's plus 9x. Because you have 10x and you're subtracting
Oh, yeah, yeah.
1x. That's 9x. Okay, and then? What's that last term? Plus 18. There we go. So there we have it. X squared plus 9x plus 18. All right, so we check for greatest common factor. Is there one?
No, 3.
There's not one because there's no number in front of
Oh,
x squared.
yeah.
Right. Okay, so we can go into A, B, and C. What is A?
1,
What is B?
9,
And what is C?
18.
So draw the... Yeah, this is a longer one. Draw the X box. What goes in the top?
18.
What goes in the bottom?
9.
So what are my two side values then?
6 times 3.
That is correct. 6 and 3. 6 times 3 is 18. 6 plus 3 is 9. Okay, what do we do after that?
Over x.
Put the x on top because it's 1 times x. And so my factors are?
X plus 6 times x plus 3 plus 0.
That is correct.
they're both negatives.
All right, hang on a second. So yeah, if you solved for x, what would you get?
-6.
And?
-3.
Okay, and this is why I said, you see that both of them are negative, right? And so what's your instinct? What do you think? Right, so you think it's no solution because you see two negatives. But as I said earlier, don't just look at the answer and see that they're negative and assume that it's not going to work, right? Plug them in first and then make your decision, okay? So this is why, because look at our equation. We rearranged our equation to where it's square root of x plus 7 equals x plus 5, right?
Yeah.
If this side with the x plus 5 ends up negative, it doesn't work, right? Because then it would say equals a negative number. But when I plug in negative 3, what's negative 3 plus 5? Positive 2, right? It ends up being a positive. So there's no problem with that, is there?
No.
Right, so you can see that that one's actually going to work. So let's plug in the negative 3. And even if you work it out, you'll see that it works. So x plus 7, so negative 3 plus 7 equals negative 3 plus 5. What's negative 3 plus 7?
Negative 4. Wait, no.
Positive 4
Yeah.
equals
4.
No, negative.
2. And look, now it says the square root of 4 equals 2. Is that true?
Yeah.
Yes, it is. So x equals negative 3 is going to be one of your solutions. See that? And even if you just check the right side, you know, negative 3 plus 5, that's a positive 2. There's nothing wrong with that.
One of them could be a solution.
2 of them could be a solution.
Okay.
It could, but is it though? Because what happens when you plug in negative 6 plus 5?
6, 7, 8, 9, 10, 11.
Negative 6 plus 5.
1. We give negative 1, right?
Negative 1. And does that work?
No.
No, because it's a negative. Right? So, yeah, if you plugged in the negative 6, you would have square root of negative 6 plus 7 equals negative 6 plus 5. And even if you work this out, you would see that it doesn't work. Because negative 6 plus 7 is positive 1 equals negative 1 over here. What's the square root of 1? 1 equals negative 1. That's not true. And so your only solution here is x equals negative 3, right? So that's why I tell you, don't assume that it doesn't work just because it's negative. Plug it in, and then you can determine, right?
Yeah.
Okay, so yeah, that one is a longer one. So that's going to be the end, though, of these notes. So until next time, see you in the next one. Peace!